All right, this is from section 4.7a. So these are my notes from there. It's special factorizations. And the only one we're really dealing with is the perfect squares. Okay, which is called a difference of squares. It's pretty straightforward the way it works. It's not necessarily you having to do any type of like finding the factor of the last number that adds to the middle number like the last lesson. You're just taking the perfect squares of what they have right here. So let's say we have x squared minus 9. Okay, well, these are both perfect squares because there's a square on this one, and 9 is a perfect square. That's 3 times 3. So the way that this is going to work out is they're always still going to go into this 2 parentheses format where you're going to have 1 plus version and 1 minus version of what you need from both of these. So 1 plus and 1 minus. So x times x is x squared, so that's what's going to come out in front. And 3 times 3 is 9, so a positive 3 and a negative 3 would get us that. And then that would be the factored form of that. So pretty straightforward enough. You're really just taking the square root of both of these things and putting the opposites on the inside. The front number is always the same sign. So even if you have a little bit more involved, like numbers in front, 9x squared minus 4, same type of thing is going to apply. This is going to split up into 2 parentheses with 1 plus and 1 minus version. 3 times 3 is 9, but since that has our x with it as well, you'll have to do 3x and 3x, not just 3. And then 2 times 2 is 4, so you'd have a positive 2 and a negative 2. So then that would be our factored form of that. 3x times 3x is 9x squared. 3x times negative 2 and 2 times positive 3 would end up canceling out. And then 2 times negative 2 is negative 4. So that's what's happening right here. Okay, it doesn't necessarily matter the order that they're going to have it in either. You could come out with something like 4 minus 25x squared. Okay, well that's okay. We could still do this. It only works for a difference of squares. So 2 times 2 is 4, so that's going to be 2 plus and then 2 minus, and then 25 is 5 times 5, and then x times x is x squared, so it'd be a positive 5x and a negative 5x. So that would be your factor form of that one. Now, what won't work is something like 4 plus 25x squared. This is not factorable. It has to be a minus. It has to be difference of squares. You can't do like 2 plus 5x and 2 plus 5x. That wouldn't give you the same thing. So for these, you'd have to say not factorable. So only subtraction is going to work. Okay, so don't do anything that'll have a plus sign to be able to make this factorable. Now don't forget that all of the earlier stuff we did with taking out greatest common factor, that still has to apply with this too. So like if we have 12 minus 27x squared. Well, these aren't perfect squares at the beginning, but remember if they do have a common factor, you have to take that out first. 12 and 27, those both divide out by 3. So remember you have to take out the 3 that they have in common first, where you're going to write that out in the front. Okay, whatever you divide out comes out in the front. And then you'd have 4 minus 9x squared after that. Then you can have perfect squares on the inside right here. So this will be our special factoring kind. So 3 would stay out in the front. Then this would split up into 2 plus 3x and 2 minus 3x. The 2 perfect squares. 2 times 2 is 4. 3 times 3 is 9. Or 3x times 3x is 9x squared. Let's look at another one like that. Now, it's okay if they both have variables as well, as long as they both have a square on them. Let's say we have 8x squared minus 18y squared. Okay, similar situation. 8 and 18 both have a common factor. It's not x or y. You have to just divide out the 2 that they have in common. They both divide by 2. That's the biggest one. So 2 would come out in front. You'd have 4x squared minus 9y squared. So that's similar to this one, but now there's an x squared also with the 4. So just make sure you keep the x with the the perfect square of the 4 and the y with the perfect square of the 9. So it doesn't matter that there's two variables. The 2 is going to stay out in the front. This is 2 times 2, so 2x times 2x plus this would be 3. So 3y times 3y. But remember, there's always 2 parentheses to this, so don't just leave it at that. Make sure you do 2x minus 3y also. Okay, not a plus version and a minus version should come out of that, and you'd have to enter in all of that. So that's all of the special factoring kind from R 4.7a.